All right, welcome back, everyone. In the remaining 25 minutes that we have left, I would like to address as many questions as I can. I think probably given the size of this crowd, the best thing to do is just going to be to have you guys drop questions into the Q&A in the chat. If things are really complicated, I can try to unmute people, but I think it's just logistically a bit difficult. So I will try and get through as many questions as I can, kind of picking out from the Q&A. I apologize. I think we've answered 83 questions and we have 78 open. So it's great to see so much participation, but unfortunately, we won't be able to answer all of them. And I must apologize in advance that at some point, I think we had over 340 people in the Zoom room. So I can't answer as much as I would like to. I would love to answer 340 different questions via email, but I don't think that's feasible in a group of this size. So I apologize that if I don't get to your question, I don't think I will be able to answer it via email afterwards. But I will do my best to try and get through as many questions as possible. And then if I'm not able to answer your question, I do encourage you to look at the DiD resources page on my website, which has a lot of other resources that hopefully will answer your question. As I said, feel free to drop questions into the Q&A. I was looking over the Q&A during the break and noticed a couple of themes of questions that have been asked in various forms. So I'm going to start with a couple of things that I've seen a couple of people ask about in the Q&A, and then I will try and answer some more questions that come in as we go along. One thing that people asked about was what about in settings where the treatment turns on and off? For example, if the treatment is a minimum wage increase, in some years states raise the minimum wage. In some years, some states raise the minimum wage, then they might raise it again 5 years later, or they may institute a plan where they're going to raise it, by a certain amount each of the next 5 or 10 years. So there's sort of treatments that may recur. This is an area that's started to receive some interest recently. There's I guess if you look at, I think it's section 3.4 of our review paper, we have some summary of different papers. I guess I would say, I think there've been kind of two approaches in this literature. The first is to sort of impose what's called a no carryover assumption or a limited carryover assumption, which basically says that my outcome today only depends on either my policy today in a no carryover assumption, or in sort of like a limited carryover assumption says, my policy today, my outcome today depends on my policy today, and maybe my policy over the last, say, 5 periods, but it doesn't depend on sort of the policy that I had a very long time ago. And so if you think about the version where the simplest version where you assume that basically my outcome today only depends on my treatment today, then if you kind of assume parallel trends between, in a given year, between places where the treatment turns on versus places where it's constant, you can kind of run these local differences where you sort of, in say 2007, I compare the people whose outcome turned on between 2006 and 2007 to people whose outcome didn't change. Or likewise, I compare people whose outcome turned off to people whose outcome didn't change. And so I can get a bunch of local differences estimates, and then I can average them. So for example, Clément, Shays Martin, Xavier Defoy have some work doing this, as well as KOSKMI and some co-authors. So that's kind of one version of doing this. And then a second version of doing that is to kind of say that, well, the treatment really depends on the whole path of outcomes. So, one potential outcome is the potential outcome where you're treated in period 1, not treated in period 2, treated in period 3, treated in period 4. That could be different than if you changed any one of those, period specific treatment things. You could then assume something like parallel trends between groups of units with different paths of treatment. In theory, everything works there. You can estimate the effect of one treatment path versus a different treatment path. One of the problems in practice is that just the number of paths gets very large. So even if you have a binary treatment, if you have 10 periods, they're like 2 to the 10th possible paths. And so you actually don't tend to have a lot of observations for each potential path in most settings. And so you have to do some kind of pooling or something like that. So that's one issue. Clément, Chaise-Martin, and Xavier Foy have some recent work about thinking about smart ways to average over those different paths. Another issue in the sort of setting where treatment turns on and off is that you might think that actually, if say the state legislature has the opportunity to change the policy at every period, that there might be feedback where if employment was really low over the last few periods, I might decide not to raise the minimum wage, whereas if employment was really high, I might decide to raise it more. So that may lead to some feedback between lagged outcomes and future treatments, that if I just assume parallel trends between all these groups ex ante, it sort of would generally not hold up if there's these types of feedback mechanisms. And so there's this alternative literature really initiated in biostats by Jamie Robbins and co-authors, but that's starting to see some work in econometrics too. So for example, Davide Viviano at Harvard is working on stuff where instead of parallel trends, you kind of assume that there's what's called sequential ignorability of the treatment. So the treatment is effectively randomly assigned at period T, conditional on the outcomes realized before period T and the path of treatments realized before period T. And I think in a lot of cases that may be sort of a more plausible model of the world than just assuming parallel trends ex ante. So it might be, for example, more plausible to say that sort of conditional on a state's employment history and its minimum wage history, it's sort of random what the legislature decides to do, rather than saying, regardless of a state's path of minimum wages, their outcomes sort of would have been parallel if they hadn't changed the minimum wage. So that's kind of an alternative approach, which is a different assumption, sequential ignorability, but maybe more plausible, especially in settings where the treatments really are sort of dynamically determined. That's starting to get a little bit of traction. So there's definitely been a lot more work in differences on sort of staggered adoption of treatment, but where the treatment is absorbing, once I've adopted the treatment, I sort of always have it. But there's starting to be a lot more work on these types of settings where the treatment goes on and off. Yeah, section, I believe 3.4 of our review paper has some more details on that. So that was one thing that was asked about. Another thing a few people asked about, which is a really good question, is spillovers. So, when we wrote the potential outcomes, YI's outcome is a function of their treatment, but in principle, it could be that it's also a function of other people's treatments. So, if I live in Rhode Island, which is a small state, right? If Massachusetts raises its minimum wage, which is the state next door, that could have spillover effects on Rhode Island because many people who live in Rhode Island work in Massachusetts and vice versa. And so kind of the usual diff and diff framework rules that out. But we might think that there are spillovers. Usually spillovers will kind of bias you towards not finding anything, right? So if Massachusetts raises its minimum wage, Rhode Island doesn't, and I do a diff and diff between them, it could be the minimum wage had a large effect on both states, but if the effect on both states was the same, then I wouldn't actually find a treatment effect when I do the diff and diff, because Massachusetts' outcome went up, but Rhode Island's outcome also went up. So when I take the difference, I don't really see any change. So when the spillovers are kind of going the same direction as the own treatment effects, we think that will generally tend to attenuate things. Obviously, if the spillovers were negative, then it would sort of exacerbate things. So if when Massachusetts raises its minimum wage, it decreases employment in Massachusetts, but those people move to Rhode Island, then it would actually overstate the magnitude. So I guess depending on whether you think the spillovers are positive or negative, it could attenuate or exacerbate. And you may have some sense from your context about the direction of that bias. I guess the other thing I would say is that often when we're worried about spillovers, what we try to do is we try to aggregate to a larger level, the units to a sort of more aggregated level, where the spillovers we think are probably smaller. So, if I have city level data, it's very plausible that there are spillovers across cities. Neighboring cities, Minneapolis raises its minimum wage, it's going to have an effect on St. Paul. It's probably a smaller effect if Minnesota raises its minimum wage for that to have an effect on, Wisconsin or something like that. And so often what people do is when they're worried about spillovers, kind of try and aggregate to a larger level. There has also been some interesting work trying to formalize some of these ideas. Kyle Butts is a grad student at the University of Colorado, has some papers on spillovers, as well as Michael Pullman, who's at Duke now, has been working on some stuff with spillovers. Again, I think that section 3.4 of our review paper has some stuff about spillovers. So those are the questions that I had sort of seen from the chat during the break. Let me now take a look to see what other new questions have come in since then. Yeah, so someone asked about different functional forms. How should we choose the functional form, or is that more an economic question, an econometric question? Yeah, so I'm very sympathetic to the statement. It's kind of an economic question. I guess I would say to just add a little bit more color to that. So I guess the choice of functional form in difference and differences determines two things actually at the same time, which is a little bit weird. One thing it determines is what is the parameter that you get if parallel trends holds, right? So if I run difference and differences in levels, then if parallel trends holds, I get the treatment effect in levels. If I run it in logs, then if parallel trends holds, I get the treatment effect in logs. And so those are different parameters, and only economics can tell you are you more interested in the treatment effect in levels versus the treatment effect in logs. That depends on do you think there are, say, like diminishing marginal returns to the outcome? Right? If you think there are no diminishing marginal returns, you just want to increase the average outcome, perhaps. If you think there are diminishing marginal returns, maybe it's more meaningful to increase the average treatment effect in logs, which sort of gives you more weight to increasing outcomes for people whose, say, income is low relative to people whose outcome is high. So I think economic considerations will tell you sort of which of the parameters you're interested in. But I guess the other thing is that with difference and differences, once you choose the functional form, you both choose the parameter you get if parallel trends holds, but you also choose the form of the parallel trends assumption. And that's a little bit tricky. Sometimes we have some intuition, if we think the shocks are multiplicative, then parallel trends and logs seems more reasonable than parallel trends and levels. If we think they're additive, then parallel trends and levels seems more reasonable. Sometimes we're unsure. And so kind of if we're unsure, we can look at the pre-trends to give us a bit of a guide, but for the reasons I discussed, that's not kind of perfect. And so that's where I think, stuff like the sensitivity analysis that I talked about is useful in the sense that, you can pick a transformation where you're actually interested in the parameter, and then, parallel trends may not hold exactly for that functional form, but our hope is that it holds at least approximately for that functional form, and you can sort of try to think about violations of parallel trends. How sensitive are you to those if you think they're relatively similar in the pre-treatment period and the post-treatment period? A few people have asked questions about comparing different estimators for difference and differences. Borsiak, Charvel, and Spies, Scally, and Santana, those estimators. I assume that's what people have in mind. I guess it's a little bit hard to answer these questions just in the sense that I haven't really said anything today about all of those estimators. So I think people may have a little bit less background as to what the differences between the estimators are. We do have a fairly long discussion of this comparison in the review paper, so you may want to take a look at that. I guess I would, but but maybe to just add a little bit of color, focusing mainly on, say, Cowley and Santana versus Borsiak, Jarvel, and Spies. If you think about a non-staggered difference in differences estimator, we just think about what would the Cowley and Santana estimator and the Borsiak, Jarvel, and Spies estimator do in the non-staggered case. There's actually one difference between the estimators, only one difference. And that difference is Cowley and Santana's estimator will look at post-treatment outcomes and then compare them to just the outcome in the period prior to the treatment and ignore the periods before the period just before the treatment, which is roughly speaking what the usual event study plot does, where you normalize period -1 to 0. And so it basically just look at those estimates comparing -1 to the post-treatment, ignoring the pre-treatment. Whereas Borsiak, Jarvel, and Spies in this simple case would sort of just average all of the pre-treatment periods, basically collapse those into an equal weighted average, and then do differences between that collapsed pre-treatment estimator and the post-treatment periods. And so from that simple case, you can kind of get some sense for some pros and cons of these two approaches. One advantage to averaging is that if the outcome is not too serially correlated, this can increase precision because you sort of averaged over many periods, and so that can give you smaller standard errors. That's not necessarily the case if the outcome is very serially correlated. So if the outcome is very serially correlated, say if it follows a random walk, actually the Cowley and Santana thing is efficient to kind of ignore the differences before the last one. So there are potentially some differences in efficiency that sort of depend on whether how serially correlated the outcome is. And then there are also some differences in kind of what parallel trends assumption that we need. So Cowley and Santana only kind of requires parallel trends between the last pre-treatment period and the post periods. Borsiak, Jarvel, and Spies sort of requires parallel trends between the average of the pre-treatment periods and the post-treatment period, which in a lot of cases, sort of hard to imagine that happening unless you have parallel trends for all of the pre-treatment periods. Of course, in general, it's a little bit hard to imagine parallel trends holding, not in many pre-treatment periods, but then it just magically holds at the end. So you might say that's not that much larger of an assumption. On the other hand, if you sort of think parallel trends only approximately holds, then at least over short time horizons, then your bias is kind of small if you restrict to short time horizons. But if you average over a very long pre-period, then you're kind of aggregating the bias of a, say, small violation in parallel trends over many periods. And so at least for, like, say, linear or monotone violations of parallel trends, Borsiak, Jarvel, and Spies can be a bit more sensitive because it's effectively using longer time horizons where there's more potential for violations to accumulate. On the other hand, if you were worried about like violations of no anticipation, then Borsiak, Jarvel, and Spies is using kind of more of the earlier pre-periods, where Cowley and Santana is only using the last pre-period, so that could be more biased by no violations of no anticipation. So I think there are some differences, pros and cons, both in terms of efficiency and in terms of the identifying assumption, that can lead to some differences. And so depending on kind of which of those scenarios you think you're in, one or the other might be better. I think practically my experience is that in most applied settings, those estimators tend to give you relatively similar answers. And in fact, in a lot of cases, the new estimators of staggered treatment timing will give you relatively similar answers to just sort of the traditional two-way fixed effects event study. There are issues with the two-way fixed effects event study in cases with certain forms of heterogeneous treatment effects. But empirically, in a lot of settings, those issues don't actually appear to be that large in a lot of settings. That's not to say there aren't settings where these things don't matter a lot. There are some settings where these things do matter, but I think empirically a lot of people have found that despite doing a lot of work to implement the new tools, a lot of the time they do give similar answers, which I guess is depending on your perspective could be encouraging or sort of why we always take our time doing this. But I guess I don't want to suggest that it's a waste of time to do it. I do think it can matter in a lot of cases, but in a lot of cases empirically it just doesn't seem to be that important. So I guess I would encourage people not to freak out too much about these new estimators. I think they're sort of more transparent comparisons of treatment and control groups, which is good, and that leads to sort of more robust things to treatment effect heterogeneity. But in a lot of cases, kind of the minor differences don't seem to matter that much in practice. Someone asks about triple differences settings. Right. So actually, I think a useful framing that's sometimes useful for other things too, like how do I estimate triple differences with the new differences estimator, is that a lot of the time actually triple differences can be written as a difference in differences where the outcome is just a difference. So if you think about like a canonical case like John Gruber's study of maternity leave, he has like treated and untreated states that impose maternity leave policies. But then within those states, he has pre-post, so that's the usual diff and diff. But then he also has male versus female. He thinks, at that time, women basically took maternity leave, but men did not take paternity leave. And so he has three differences: men versus women, treated versus untreated states, and pre and post policy change. So the usual triple diff is like, treated minus untreated, pre minus post, women versus men. But you can sort of think, if I think about the outcome at the state level, that's difference in outcome between men and women, then I can think of the triple diff as just a diff and diff on the outcome, where the outcome is the difference between men and women in that state. And so I can sort of cast the triple difference as actually a difference in difference using that difference outcome. And so then once I have that as a difference in differences, I can actually think about it in the same ways that I was doing before. And so I can sort of think about testing. Did I have parallel trends for that difference outcome beforehand? I can sort of plug it into any of the new estimators for difference and differences and think about violations of that assumption. So I think kind of casting stuff as casting a triple diff as diff and diff can often take you a long way in terms of thinking about these types of things. I have 3 minutes left, so I think I will take one more question. Let's see. Oh yeah, and then I guess I see here a question about covariates. There are several questions about covariates. So yes, so I think differences can often be more plausible conditional on some covariates. And so there are a variety of methods for that. If you take a look at, I think it's section 3.2 of our review paper, we talk about a bunch of different methods for controlling for covariates. Parallel trends would generally be more plausible when the groups are more similar, and so controlling for covariates can be a good thing to do. Of course, we might also worry about sort of differences on unobservables, and so I think the types of sensitivity analyses that I talked about today are sort of complementary with approaches that try and balance covariates. So you first try to balance the observable covariates, and then you worry about unobservables. So you can do methods that condition on covariates, and then apply that sensitivity analysis tools that I talked about to deal with the remaining potential unobservables. And so that can potentially help things. I guess that took me only 1 minute, so I guess I have 2 minutes left. So let me see here. What else can I answer in the chat? Someone asked about how is event study different from canonical difference and differences. Because I was in the canonical case, you just have 2 periods, one before and one after, so you can't test for pretrends. But in practice, in most diff and diff settings, we have more periods. We have more than one before and often more than one afterwards. And so we can construct what we call an event study. Typically what we're doing is we're doing a bunch of different difference and differences relative to the period before the treatment occurs. And so the pretreatment ones are doing diff and diff between, say, period -3 and period -1, period -4 and period -1, so on. And the post-treatment ones are doing diff and diff between period -1 and post-treatment periods. And so we can kind of sort of follow the evolution of the trends for the 2 groups over time. And the ones beforehand tell us something about the plausibility of the parallel trends assumption. The ones afterwards, if we believe the parallel trends assumption, tell us about the treatment effects. So I think that's what I have time for today. I appreciate all the questions. Thanks so much for engaging with this and for listening. And best of luck in all your different diff adventures. So thanks very much.